Olá, Eduardo.
There you are, Dr. Eduardo Couto. Please start. You have 10 minutes each because everyone is short of time, but I'm sure it'll all work out.
Me diga só se vocês estão vendo a apresentação.
Please tell me if you can see my presentation. Just a moment, please. There, it is in presentation mode, isn't it? Good.
And I was told that we have an opportunity here to strengthen partnerships between Brazil and Germany. So I will give you a brief description of what we think could be a potential for partnerships. I'm from the Brazilian Center for Research in Energy and Materials, CNPM in Campinas, which is located 100 kilometers from São Paulo. We are accredited as a biotech unit by the Brazilian Company of Research and Industrial Innovation. And we are a private non-profit research organization that operates under management contract with the Brazilian Ministry of Science, Technology and Innovations. We have 4 national labs, a nanotechnology lab, biosciences lab, particle accelerator national lab that built the state-of-the-art synchrotron light source called Sirius, and then I direct the Brazilian Biorenewables National Laboratory. CNPM has an impact in different sectors from energy, health, agriculture, environment, and important here for the discussions with Germany is industry. In particular, I want to highlight the chemical sector. CNPM is also embedded in an innovation ecosystem. So you have a radius here of about 120 kilometers centered in the city of Campinas. The black triangle, the big one, is CNPM. The red ones are the research centers, about 9 or 10. And then we have 3 top higher education institutions in the country in the pink triangles. You also see the squares are the industrial sectors that are present within this region. We have 3 major airports and the Port of Santos in the very bottom here that contributes to 25% of the Brazilian trade flow. And very important to the discussion of today, sugarcane mills that can provide us biomass for also industrial applications, energy, and so on and so forth. And everything is within an hour of CNPM. The challenge we're trying to face is that we all know how hard it is to electrify the long-haul transportation sector, but there is also a perception that the petrochemical demand will be larger or will be increasing faster compared to the demand for energy. And we all know that this model of industrial production has been very important for the economic development, but now we're asking about the environmental impacts. And if you look at Brazil's comparative advantages, we look at our biomass, which is abundant, cost competitive, and diverse. And we have also very rich biodiversity and that we can extract either plants or microorganisms, very important for LNBR. So LNBR is positioned itself to use biomass and its residues as a feedstock for a model of biorefinery in which we can produce energy and biochemicals and through biotechnology consolidate a new model of industrial production, which is more sustainable. This opens up opportunities for the consumer products because enzymes, especially industrial enzymes, are of utmost relevance. And we have advanced materials, food and beverages, feed, and so on and so forth. So if you look here at we are agnostic to biomass. So Brazil has a very diverse options and we want to explore them. And we can apply our technologies to transportation, industry, and agriculture. Here, we don't focus on the biomass, nor on the molecule that you're trying to produce in industry, but rather at the platform. And the LNBR work focuses then on developing biological platforms of high performance and industrial relevance. You can read this as microorganisms and industrial enzymes. We operate under three pillars: understanding matter, biological matter at the atomic and molecular level, developing the conversion technologies, and then designing, integrating, and optimizing processes at a pilot plant scale. We also have a group that works on techno-economic and environmental assessments and product lifecycle analysis. Plus, we have experience with integrated production chains, feedstock supply, and logistics. And being accredited as an EMBRA-P biotech unit, we are flexible and agile for R&D partnerships and technology licensing. So let me show you a few of our core competencies that we think are disruptive and groundbreaking, which is the understanding of complex biological systems. We use multiomics, structural and molecular biology, and synthetic biology to produce and understand the mechanisms behind biological platforms of high performance and industrial relevance. A few highlights from LNBR. This is work we've done under the International Energy Agency, harmonizing models for greenhouse gas emissions, comparing models from the European Union, Canada, United States, and Brazil. This is very important for the development of biofuels. Recently, we also complete a project with Global Environment Fund, managed in Brazil by the United Nations Development Program, which is the utilization of sugarcane residues, in this case, trash that is left on the field, over harvesting, for the production of electricity, therefore reducing greenhouse gas emissions. And on the more scientific side, we recently released the basis of a future biochemical platform in Nature Chemical Biology, which was highlighted as a news and views due to the discovery of these new enzymes for industrial applications. And we also have worked with companies that we publish also in the Nature Index publication, JBC, about industrial enzymes, in this case, working with cattle rumen microbiome, with one of the largest companies in the world, an American partner for this development. Here I want to highlight a particular result. On the y-axis, you have enzyme concentration going up to 100 gamma liters, and time on the horizontal axis. The world record for a research institution comes from Finland. It's a well-known world-class institution, VTT. And what we've done was to develop then a cocktail, an enzyme cocktail for cellulosic ethanol production, second generation based on residues. And this is twice as more, has a performance twice better than VTTs. And if you think of leading companies, they are probably close to 100 gamma liter. This is a secret. You never know what this number is. But the advantage of this Brazilian enzyme cocktail is that it has been tailored for the Brazilian biomass and the Brazilian environment. So it's cost competitive because we're thinking of on-site manufacturing. And interestingly enough, has been done using rational design in a public strain. That's a novelty. And obviously, it has been tested for industrial conditions. We also scaling this up. We have a semi-industrial scale pilot plant. We have partners to work on biofuels, major partners in Brazil. We also have startups working in bioprocesses with us. We open up to other areas beyond biofuels with American companies, well-known, and also expanding to biochemical with Chinese partners. So our pilot plant goes up to 300 liters and is designed to be a scientific environment for testing bench ideas from the lab and also facilitate transfer of technologies. If you were to remember one slide from my talk, I would like to be this one. The core competencies of LNBR are biological platforms and biocatalysis. Looking at the future, we see decarbonization, synthetic biology, and microbiomes as the tendencies we want to follow. And my last two slides, this is just summarizing. If you're looking for partnerships with us, we think we are well poised to be at the frontier of biocatalysis because we also have quantum mechanics and dynamic simulations and we understand experimentally using cryomicroscopes or synchrotron accelerators the properties and mechanisms of biological matter. And all this work is then translated into scaled up processes in our pilot plant. This combination of capabilities is quite unique for institutions worldwide. And this is my last slide, so I would like to thank you all for the opportunity and just leave the message that we're here to accelerate transition from a fossil-based industrial production to a new bio-based one, using microorganisms, biomass, which are Brazilian differential competitive or comparative advantages, and reducing environmental impacts with a responsible use of natural resources. Thank you very much.
Obrigada, Eduardo. Excelente apresentação.
Thank you very much for your excellent presentation. I'm sorry for giving you little time, but you were perfect. Thank you very much. This presentation will also be available. And Professor, I would like to ask you kindly, Dr. Unkelbach, if you could allow Dr. Kleber Suarez to make his short presentation before you do, so that you have more time and are more relaxed during yours. Is that all right? Thank you. Well,
Yeah,
Kleber, the floor is yours. You have 10 minutes. Thank you. Well, thank you very much, Bia. Good morning to everyone. It is a pleasure to be here. I'm going to make a few remarks. I'd like to thank you, Maria Beatriz Costa, the great event, Green Rio 2020, Green Rio. Well, I'd like to greet Dr. Eduardo Couto. It's always a pleasure to meet you and see you. And Dr. Unkelbach. I will mention a little bit about our views in the Ministry for Agriculture. Also speaking on behalf of the Minister, I would talk about the potential use of biomass as a whole at 3 levels. First of all, I'd like to talk about the different areas and applications of biomass in industry. Secondly, in terms of the opportunities that we have for applications and uses and other biomass byproducts based basically on the agricultural component. And thirdly, the practical transformation applications in Brazil for transforming biomass into wealth. Now, in terms of challenges and opportunities, we must signal that when we talk about biomass, we are in no doubt that biomass essentially is crop byproducts, or basically soil-based, derived from plants, microorganisms, or others. We are in no doubt that the great component in biomass is derived from agricultural activities, either and others. Therefore, the Ministry for Agriculture has considered the challenges and opportunities, not just in biomass applications, but also other fields, as Secretary Fernando Schranks mentioned at first when he talked. Now in May, we launched the National Bio-Inputs Program. It has an impact, including an impact in Germany. Great companies such as BASF, headquartered in Germany, have reviewed their programs in the production of assets in Brazil because they have looked at the different sides. Now we are considering the lines of advanced biotechnology. As Dr. Eduardo Couto said, the transformation or the use of tools and biotechnology and nanotechnology tools and others in advanced technology, in the field of advanced technology. We are also looking closely at the biofuels components, either resulting from biomass or sugarcane or other products or raw materials that are grown in the case of plants, and even animal-based in the case of oils or fats. And we are considering with great attention the biomass components based on our genetic resource matrix. Brazil has about 20% of the mega biodiversity on the planet, and this has a potential for transforming the wealth of our mega biodiversity. Now, that having been said, it's important to see clearly that when we talk about bioeconomy or biomass, the main element is carbon, carbon and carbon. Everything that we derive from the use of bioeconomy, well, the main molecule is carbon, either in terms of biomass or other means or ends. Now, we are considering the opportunities, the business opportunities and adding value, and the developing of new assets and new technologies derived from biomass and along different lines. The use and the extending of the renewable energy matrix, biomass matrix in Brazil. Over 80% in Brazil of the energy matrix is supported by renewable energies. Nearly 10% of those are derived from biomass and biogas. But we have an opportunity, both in Brazil and in the tropical world, of increasing that level. Why? Because we have a gigantic amount of billions of tons of biomass derived from our crops. In the same way, the application in the bio inputs derived from biomass, such as biofertilizers and applications associated to animal feed. We have over 200 million heads of cattle in Brazil, and also so much poultry, and we need to produce more protein. The world is going through a chronic hunger moment. At the beginning of next year, we will have a great number of people facing hunger. So we must try and convert biomass into protein, mainly animal protein, either milk, meat, whatever. Now, along this line, in terms of nutrition, we must also consider biomass for generating food or human food, nutraceutical components, health components, food components. We know that in Brazil there is already research. For example, Embrapa Agroenergy developed a strain or improved a strain of microalgae that are hyper producers of beta carotene, and we have a deficiency of vitamin A in the tropical regions. So we are strengthening these alternative biomass lines with other applications. In the same way, in terms of the industry, well, we would like to stress the use of biomass in the industrial applications. For example, textiles, for developing new textiles and enzymes for improving the texture and the quality, the elasticity of textiles, as well as other lines such as the application of byproducts for biomass byproducts for cosmetics. And we have the opportunity of developing aromatics and alcohols with great added value, especially for fine cosmetics and perfumes. And also, why not use our biomass, considering our mega biodiversity in Brazil, for developing pharmaceutical products, new drugs, new molecules, new antibiotics. And in the same way, we could use these biomass byproducts for therapeutic applications. We have technologies developed by Embrapa for Leicester and Klabin for different ways of dressings. With a view to the future, I would like to close that we do not doubt that the future of mankind is based on three main aspects: agriculture, everything that is derived from the soil, bio and biomass is within this, and the digital. Now, all this for the explanation of our genetic resources and biomass. All this will have a very main role, an essential role. Well, I'd like to thank you for the invitation. Thank you very, very much. Thank you, Kleber. You've been talking about the great leap that you talked about. And I think that's what you talked about. You're ready to take the leap. Thank you very much. I thank you. I thank Eduardo Kleber. And now please, Professor Enkelbach.
I'm sorry for this changing, but I'm sure that you're going to do a fantastic presentation.
Yeah, thank you very much also for inviting me and giving the chance to talk about some biorefinery projects at the Fraunhofer Center for Chemical and Biotechnological Processes, where I am the leader of. Yeah, strongly supported by the Federal Ministry of Education and Research and the Ministry for Food and Agriculture, we erect a pilot facility, an open access pilot facility in Germany, for exactly piloting biorefinery processes, meaning pre-treatment of biomass, the biotechnological or chemical transformation, but also related to downstream processing of the product, that you have specified products at the end for fine chemical purposes, for platform chemicals, or even for food or nutraceutical applications. So at the Fraunhofer CBP, we are bridging the gap between lab scale and the industry. And I would like to give you some insights, but first I would like to show you some of the principles related to biorefinery setups. So first, there are two strategies. The first one is a so-called bottom-up strategy, so that you go to existing sites, for example, sugar or starch or pulp mills or plant oil production sites, and you integrate further process steps. The second activity would be a so-called top-down approach, where you erect completely new, highly integrated biorefinery systems. Yeah, like a chemical setup, for example, for lignocellulosic or green feedstocks. For the products, we are talking about three different options. You can produce bio-based drop-in chemicals. So the molecules are exactly the same, but they are based on biomass. Then you can use you can produce smart drop-in chemicals, which are also chemically identical, but the production pathway have some benefits, like we heard about enzymes, which are more selective compared to a chemical process, for example, saving some energy during the production. And last but not least, dedicated bio-based chemicals, which are not chemically identical with the substitution product, but which can offer new opportunities, new functionalities, and of course, new markets and business applications. And one of the interesting feedstocks for us are lignocellulosic biomasses. So therefore, I show you some processes which we develop based on woody biomass. If you look at it on a chemical perspective, you have four different components: hemicellulose, cellulose, two sugars, the lignin, which glues everything together, and then extractives, which can be used also for medical applications. And if you look in more detail, you have to disrupt this structure. This can be mechanical or chemical or also physical chemical. One of the projects which I would like to present is so-called CombiChem Pro. So we are dealing with the production of fine and platform chemicals. If you disrupt the lignocellulosic biomass, you can produce chemical pulp, which is done since more than 100 years. in a very efficient manner, but you can also use the hydrolysate as a feedstock for fermentation. The C5 sugars coming from the hemicellulose can be converted chemically or also biotechnological to platform chemicals, which you can use for packaging. And the lignin we extracted, we cleaved to phenols for also bioplastic, but also for adhesives and resin applications, which you see on the right-hand side. Depending on the C source, for example, the C5 sugars, you need different production strains also for the production of different chemicals. For example, xylonic acid, which you can use as a chelating agent, for example, or as a monomer for polymer production. We scaled this process up and we developed first purification strategies within the project. The second example is malic acid. It's a different strain. You see it on the right-hand side. And we also scaled this up. And this is an interesting molecule for the food and beverage industry, but also as a potential building block for 1,4-butanediol as a precursor for polymers or resins. So the project was very successful, and within a joint development with the German Biomass and Research Center located close by in Leipzig, we have now the processes ready for industrial implementation. If you are able to combine pre-treatment processes like I present you with different extraction techniques, for example, local beechwood can offer also the opportunity to produce pharmaceutical grade xylanes. So first, in a coupled process, you extract the xylane, and then you do a different, harsher pre-treatment to extract lignin, and you receive the pulp or also glucose as a product. So you have a very high material efficiency that offers very good business case opportunities. And we reduce the ethanol use for the extraction of the lignin, for example. And also these materials are at the moment available after the scaling up of the process in kilogram scale for application tests. A third example I would like to show you is a European project called Unravel. And here we use our existing piloting facilities for scaling up another pre-treatment process called Fabiola, developed by ECN and TNO. And we scaled the process up to TRL5, offering the opportunities to produce also a broad variety of products. So you see it on the right-hand side for pharma-grade betulene or suberin products, different chemicals, but also fuels. Some examples: during the scale-up, we measure kinetics. We developed it up to TRL5 or TRL6 at the end. We do kinetically investigations, and on the right-hand side, also at the bottom, you see some polyurethane foams based on the lignin we extract from the biomass. So we have a lot of opportunities here. Two other examples I would like to point out in the plant oil business, so to increase value for the plant oil industry. One of the processes we developed is an enzymatical epoxidation of fatty acids. So the matrix you see on the left-hand side is based on linseed oil, but you can use this process also for all kind of unsaturated fatty acids. And together with a bio-based hardener system containing some bio-based molecules, including also modified lignin, we produce different polymers or even foams in a two-component epoxy resin formulation, also for paints or also for floor coatings. This is the material application for fatty acids or plant oils. But also in the food and feed business, you have new opportunities if you look on new technologies. For example, we developed a process called Etana. It's the native extraction of peeled rapeseed. And with this process, using only alcohol as an integrated solvent, so it's completely recovered, you can extract 4 different products coming from the rapeseed. Classically, you receive only the oil and a press cake, which you can use for feed applications. These are here in the picture, the upper 2. But with the alcohol extractions process, you can also achieve a very, very high protein concentrate. And also the secondary plant ingredients can be extracted in a high selectivity and high yield. And this you can also use for additives for food or feed. So this giving plant oil producers other opportunity, other business opportunities. And at the moment, we are scaling up also this process to achieve ton scale of protein for testing in animal feed application, but also for human nutrition, for example. I would like to sum up with some suggestions. So mostly we see that an organic growth of biorefinery activities, starting with the so-called first generation raw material, I mentioned sugar, straw, or plant oil, would be beneficial. And you should prefer to manufacture smart drop-in or dedicated bio-based chemicals because you have then better business opportunities and there is no substitution only in your product. Fine and specialty chemicals facilitate the market entry if you are going for a biorefinery setup. And only a few products or coupling products should be produced within one factory. You need very strong partnerships, and therefore I like the idea also to join forces between crossing all the borders. And we are using all the technology demonstration facilities you heard in the last presentation, and also in Germany we have the possibilities to do this technology demonstration to increase the market pull, because with the scale up and demonstration you have access then with these new products to the market, and you pull attraction. And yeah, please feel free to write me an email afterwards or give me a call. And because the Fraunhofer CBP is an open access platform, especially for scaling up bio-based processes, and looking forward to the discussion and the next presentations. Thanks a lot.
Thanks a lot, Professor Ankelbach. I'm very proud that we have here Fraunhofer, which is such a prestigious institution, and that you represented so well. Muito obrigada, professor Ankelbach. Nós estamos muito orgulhosos de ter aqui representante.
It is a great honor to have a representative from Fraunhofer Center. It's an institution we respect a lot. Your presentation will also be available, and I'm sure there will be many questions. With this, we close the industrial use of biomass. And now we're going to go on to the next panel under the call, which is the panel on medicinal and aromatic plants. I'd like to invite